We're given a right angled triangle and there are integer lengths on for A, B, and BC. Note, not necessarily AC. So the F lies on AB, and basically we create this rectangle in the middle. And then we've got some lengths denoted as well. So first up, we're given that A is 2, C is 6, Y is 3, and we're asked to find X. Now this is a similar triangles question. There's in fact 3 similar triangles. There's the large triangle, and there's the smaller two. It actually makes life a little bit easier if you deal with the smaller two. I'll talk about why in a minute. So if I draw these, and I suppose we could prove that they are similar triangles. So you can see the large triangle. Well, this has got to be a right angle. Actually, it's a right angle on both. And then the purple triangle shares the top angle with the large triangle. And then because these are parallel lines, then this is the same as well. And therefore, they must all have the same, like this angle must be the same as this. And therefore, they're similar. They're not necessarily congruent, or they're not going to be congruent, but they do have the same angles, and that's enough to show that they're similar. So drawing the purple triangle in isolation and then the green one, we've got X, 6 can go here, and the green triangle, 3 and 2. Now we can see the scale factor is just going to be 2. Times them by 2 here. Or an alternative way is to say 6 over 3 to give the scale factor is equal to x over 2, which leads to x equaling 4. So I briefly mentioned the fact that you could use the big triangle, because normally in similar triangle questions, that's what you end up doing. You don't have like 2 similar triangles being created. So here we would end up with at the bottom 9 and at the top x plus 2. And then the best approach here would be to use the black and the green triangle and see that the black triangle is 3 times as big now. So x plus 2 over 2 must equal 3, and from that you get 4 as well. You could, if you wanted to, use the black and the purple, and then you'd have to go with x plus 2 over x. This is the most complicated way of doing it, because you end up with a fraction with x on the top and the bottom. But it would still work. You get 6x plus 12 equals 9x, 3x equals 12, and hence x equals 4 that way as well. After the main part, we're told that the area of the triangle is now 9 centimeters squared and the dimensions are a whole number of centimeters. Find all possible values of BC. So immediately we can write down that AC is equal to 9, and this gives some different arrangements. We could have A equal to 9 and C equal to 1, or A equal to 1, C equal to 9, or A equal to 3 and C equal to 3. This would give a square, but a square is actually still an example of a rectangle, so that is absolutely fine. Now, one way to do the next bit is to do a case-by-case basis, start substituting for A and C. But actually, if you just pause a moment and work more generally, you can get to the solution even more quickly. But case by case will 100% work. So I'm not gonna use the big triangle now because I explained why that was more complicated. So we've got the red triangle and the green triangle, and now I've got Y and A, and then X and C. So I can write down that X divided by A, that will give me the scale factor to go from the smaller one to the larger one, will equal C divided by Y, another way to do it. And I can rearrange this equation to give xy equal to CA, which is also 9. And I can actually just do everything all in one go. So x can equal 9, and y can equal 1, and so on. And what I'm going to do now is create a table of values. which ultimately, remember, we want to find out BC, which is y plus c. So for x, I can have 9, 1, but then I could have c as 9 and a as 1, or I could swap these around within the 9, 1. So ultimately, I'm going to get 9 solutions for my triangles. I could do exactly the same again, but this time 1, 9, and then 3, 3 as well. It's quite a nice way of just writing down all your solutions in one go. Brilliant. Now finally, to work out y plus c, we're going to get 10, 2, 4, 18, 10 again, 12, 12 again, 4 again, and 6. So BC can equal, let's just write them in ascending order, 2, 4, 6, 10, 12, or 18. So that is an optimal way of dealing with this question. Just working out the different values of A and C, creating this equation just makes life so much easier, realizing that you get the same kind of, you know, arrangements, putting it all on a big table, the results just come out really clearly, writing them down the right-hand side, and then just identifying the ones that are not the same. So we don't actually get 9 solutions overall. 1, 2, 3, 4, 5. We get 6 solutions because the 12s are repeated, the 4s repeated, and the 10s repeated. Just want to say though, like if you don't spot that, doing it case by case, saying, for example, A is 9, C is 1, putting it in to this equation and rearranging it each time will absolutely work fine. You get the same answers. I'm just showing an optimal method that obviously does work really nicely. Well done.